Welcome to the latest edition of Clean Critically. These are some short videos that we've prepared for you to give you excellent ideas for manufacturing, and it's brought to you by the Product Quality Cleaning Workshop team of myself, Darren Williams, and the cleaning lady and the rocket scientist, Barbara and Ed Koenigsberg.
And here's how you can reach us, which we welcome.
Yes. So what should you use for critical cleaning? We're really looking into this one as comparing water or solvent or both in some sort of hybrid process, or maybe even non-chemical cleaning. So Barbara, what do you mean by non-chemical cleaning?
It means whatever the health and safety officer doesn't quite recognize as a solvent or an organic solvent.
I see.
So like plasma chamber cleaning
Okay,
is considered non-chemical, but they're all generated in situ.
Yeah.
CO2 snow is considered non-chemical. Steam is considered non-chemical. I think they're chemical, but yeah.
That's right.
So cleaning is removing the soil, and we define that as matter that's out of place. So how? Well, you can dissolve the soil, but that's really only part of the picture, because most cleaning processes used TACT,
I got a lot of tact.
TACT,
Yeah.
which
Yes.
is an acronym for temperature, action, cleaning agent, or chemistry, and time.
So we all know what a solvent is, right?
Well, there's some debate according to us.
Yeah.
Yeah, you know, you get a solution and it stops making a mess and it just turns to one clear thing. Okay.
But
In the world of critical cleaning and surface prep, water is a solvent. Silly me, I always thought water was a great solvent because you put sugar in your tea or coffee and that's the solvent. But in the world of cleaning, surface prep, and residue removal, solvent equals organic solvent.
it's a terminology.
And organic solvents contain carbon, and organic solvent does not mean raised without pesticides. It could be synthetically made or plant derived.
And so what does the solvent do? Well, it's the thing that removes the soil and the residue from the surface. And the reason there's so many varieties is because we have so many different types of soils and residues. So we're trying to remove them in a timely manner and to the desired level, and we're trying to prevent damage to the substrate. And so this sort of puts some parameters on the types of solutions that we use to clean our surfaces, whether it be an aqueous solution or a solvent, an organic solvent.
So really the make or break question is, does this new process, aqueous or solvent or unicorn juice, whatever you want, remove the soil and not damage the part?
Or you.
Or you.
Or
Well,
you, yes.
Depending under the you can control it from damaging you.
Yeah.
Of course, there are a few other choices. Oh, well, process costs, what the customer requires, if you can get insurance with a new process, will the cleaning agent be available? What does EHS demand or try to cajole you to do? And then what happens at the corporate policy level, and corporate policies might be tighter than regulatory constraints.
In addition, there are many other factors that influence the cleaning agent performance, because you have the chemical attributes, you have single molecules, blends, additives in blends. You consider the solubility, the wettability, how well does it flow in to actually reach the part and flow out with the residues, and just other physical properties of the chemical cleaning agent. And then again, tact.
And
Ah,
so we
yes,
talk about a lot of these things in our aqueous course, don't we, Barbara?
yes, we do. And we've heard it described as more fun than a bubble bath.
Mhm.
We hear that it was informative. That's always good, and it features education, continuing education credits, a discussion with a PQCW instructor, and low pricing. So are solvents bad and are all aqueous products good, or vice versa? I think we all develop tunnel vision or maybe puppy vision. What should you do next? Well, we suggest you call a truce, expand your horizons. All you hydrophobic engineers, get over there and shake hands with the hydrophilic engineer. All you hydrophilic engineer, shake hands with a hydrophobic engineer. You'll discuss and talk to them. You'll discover more cleaning options and more effective processes.
Let me give an example of this. I would probably have been a hydrophobic engineer because I had so much experience with solvent cleaning. And then going to the various like parts cleaning conferences and then interacting with people on these webinars, I learned a whole lot more about aqueous cleaning. And so now I feel comfortable in both methods.
That's true. That's true. We're all evolving.
Yes.
So that concludes our little tidbit for today. Please enjoy this and our other offerings.
That's
And be
right.
sure to subscribe.
You can subscribe to the PQCW channel and hit that notification bell. And then we will have this whole series on a playlist, the Clean Critically playlist. So look at all our other short videos and learn how to clean critically.
Please, I can't say it.
I
Can I?
can't say that.
That's okay.